I'm Algebra Annie, and I am here to help you be successful in your algebra class. Try to be a rainbow in someone's cloud. Amaya Angelou. Our learning targets today are: I can evaluate and multiply by powers of 10. I can convert between standard notation and scientific notation.
Now we're moving on to powers of 10 and scientific notation. Now first we need to discuss what is the difference between find the value and simplify. Find the value means if it came out as a fraction, I want you to give me the decimal. Or if I just want you to simplify, I want the fraction. So if I ask you to find the value, I want the decimal. If I ask you to simplify, I want the answer to remain as a fraction. You're not allowed to give me decimals if I ask you just to simplify. Now, why scientific notation? Scientific notation came to exist when we had to represent really big numbers that would not fit onto our calculator or really small numbers that wouldn't fit onto our calculator. Really big numbers like how far is it from Earth to the moon or Earth to Mars or just the distance between the planets. Or small distances like how wide is a hair or how small is an atom. Those are really, really small distances. How can we represent a really big number or a really, really small number? Scientific notation is the answer. Today I want you to find the value. This means I actually want the decimal. If you end up seeing a negative exponent and we're asking you to find the value, this negative exponent means that we want a really tiny number. So if I had a negative exponent, that meant I had a really small number. So if I had 10 to the negative 3, what would it be if we used our old math? So what we learned last time, if we'd use what we learned last time, that this meant he was in his unhappy place. So if you put him in his happy place, you would have had the fraction 1 over 10 to the third. And this would have simplified out to 1 over 1,000. But I want you to find the value. What is the value of this? What's the decimal? If you found the decimal of this, you would have done 0.001. So 1 divided by 1,000 on my calculator is 1/1000th. So there is my 1/1000th. If I had a positive exponent, that means I needed a bigger number. So a positive exponent means I want a big number. Well, 10 to the second power, we know that means 10 times 10. We know that means 100. So if I have a positive power, I'm going to be bigger than 1. If I have a negative power, I'm going to be smaller than 1. Well, what do we know from our last lesson? Anything raised to the 0 power is 1. So let's just practice a few more times. What does it mean to find the value? It means I want the decimal version of these numbers. So 10 to the negative second power, he was not in his happy place. He needs to be in his happy place. So there he is in his happy place. I know that 10 to the second power is 100. So I have 1/100th. You can type that into your calculator, or if you remember what 1/100th looks like, this is the decimal 1/100th. A negative exponent means a number smaller than 1. A positive exponent means I'm going to be bigger than 1. 10 to the fifth power means 10 times 10 times 10 times 10 times 10. 10 is multiplied together 5 times. Well, if you know your tens trick, that means we have 5 zeros. So 1, 1, 2, 3, 4, 5. So it's 100,000. Positive power means I have a number bigger than 1. Positive power means I'm going to have a number bigger than 1. If it has an exponent of 10, that meant that this 10 was multiplied together 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you type that all into your calculator, you're going to end up getting a number that we actually can't even type into our calculator. That meant you had a 1 and you had 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Oops, comma doesn't go there. It goes there. So what number did we actually end up getting? This would have been your thousands, millions, billions. So we ended up having 10 billion as our answer. So now we're going to go backwards. If I give you the really big number, that probably won't fit into your calculator. If I give you the really big number, can you give it to me with a base of 10 raised to some power? Can you give it to me in a method that we just did? So if it is bigger than 1, we know that we had a positive power. So this is bigger than 1, so I know my power is going to be positive, so I have 10 to some power. I know my power is going to be positive because this number is bigger than 1. How do I figure out the number? You count the number of zeros. So I had 1, 2, 3, 4, 5, 6, 7 zeros. So I had a positive 7. So 10 to the positive 7th would have been this number. Let's go ahead and do this one. If this is smaller than 1 from our previous lesson, you know it's a negative power. So I have 10 to some exponent. Because this is smaller than 1, I know this is going to be a negative power. But how do I figure out what the number is? Count the zeros. 1, 2, 3. So it's a negative 3. Looking at the problems we did earlier today, can you see that pattern? Negative exponent meant smaller than 1. The number was 3. There were 3 zeros. Negative exponent meant the number was smaller than 1. Number was 2. 2 zeros. Positive exponent meant the number was going to be bigger than 1. Number was 2. 2 zeros. Positive exponent meant the number was bigger than 1. The number was 5. There were 5 zeros. This exponent is not positive nor is it negative, so we'll just state as 1. This is a positive number, so we're bigger than 1. The exponent was 10, so there were 10 zeros. Pattern holds true. So let's go ahead and apply that pattern to some more problems that we have. They want us to write the number as a power of 10. So I meant 10 to some number. So I have 10 to some odd number. This number is bigger than 1, so it's going to be a positive power. Count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 zeros here, so it's a positive 8. So 10 to the 8th power would have given me this number. For the next one, I need 10 to some power. This number is smaller than 1, so my exponent is going to be negative. Count the zeros. 1, 2, 3, 4, 5. There were 5 zeros, so it's 10 to the negative 5th. Next number, I need 10 to some power. This is smaller than 1, so it's going to be negative. I see 1 zero, so it's 10 to the negative 1. Okay, so now we have a bunch of numbers, and we want to know, what do these numbers really mean? They want us to find the value, which means decimal is what I want. So I see that I have a positive power. Positive power means I'm getting bigger. If a positive power means I'm getting bigger, then that means my decimal point needs to be moving the bigger direction, which is to the right. So if I have 97.86, it's telling me I need to move 6 spaces to the right, because that's where the bigger numbers are. So 1, 2, 3, 4, 5, 6. You had to move 6 spaces to the right, and we would have found our bigger number. Now, what do we do with all these empty placeholders? You go ahead and you put a placeholder of 0. So we have 97860000. Our new decimal point is right here. So this is the really big number that wouldn't fit into our calculator. That is what this number represents. Same thing. We have a negative exponent. Negative exponent means your number is getting smaller. It means your number is going to be smaller than 1. Smaller numbers will go to the direction of left because those are all the smaller direction. So I have 19.5. I need to get smaller by 4 place values. So 1, 2, 3, 4. There's my new decimal point. You got to fill in your empty placeholders. So 0.00195 is the value for this expression. Our next one, it is a positive exponent, which means I need to get bigger. The numbers on the number line get bigger going this direction. So I have 853.4. I need to get bigger by 5 place values. So 1, 2, 3, 4, 5. That's 5 place values. 5 place values. Empty placeholders get my zeros. So I have 853410000. There's my new decimal place. And this is our really big number from that expression. There's a couple more practice problems. If I have a negative exponent, that means I need to get smaller. Numbers on the number line get smaller when they go this direction, which means my numbers need to go that direction. I have 0.163 is what I was originally given. I'm supposed to get smaller by 2 placeholders. So 1, 2. My new decimal goes right there. I have to fill in my spot. So I moved 2 placeholders. So I point 00163, and this is the value of that expression. I have a positive power, which means my number needs to get bigger. Numbers get bigger on the number line moving to the right. I was started off with original 3.5. I need to get bigger by 11 placeholders. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This was 11 placeholding moves. There's my new decimal point. Each spot gets a 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. So 3, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. New decimal point. And then every third represents a new place value. So we have the value for that expression. Last one, negative exponent means I'm getting smaller. Numbers get smaller on the number line when they're moving that direction. So I have 9.98 was the number I was originally given. I'm supposed to get smaller by 2 place values. 1, 2 place values. So I moved 2 spots. That empty spot needs to be a 0. So I have 0.0998 is the value for that expression. So why did scientists come up with numbers to be put into scientific notation? So numbers really, really big or numbers really, really small are hard to do arithmetic to. If you can put it into scientific notation, it's easier to do arithmetic on. So let's go ahead and change these to scientific notation. Now, what is scientific notation? There is a specific format for scientific notation. You need a single digit, a decimal point, and then you can have all the other digits following along behind, and then you have to multiply by 10 to some power. This digit right here has to be a single digit between the numbers of 1 and 9. So this is a single digit, not a number. This is a single digit between the numbers of 1 and 9. Everything else follows behind it, and then you multiply it by 10 to some power. So let's go ahead and look at this. Where is my decimal? My decimal is currently right here. So on the very bottom, I'm going to write, I need something times 10 to a power. This is what I'm looking for. So is this number bigger or smaller than 1? Our number is bigger than 1, which means I know that I get a positive power. So my number was bigger than 1, so I got a positive power. So I put a little plus sign there so I remember it's a positive power. Now, we don't want our decimal point here. To make it be into proper scientific notation, I need my digit, 4, and then my decimal point needs to go right there. So I need to move this decimal point back until it gets right here. So he's going to be moving 1, 2, 3, 4, 5, 6, 7. He is moving 7 placeholders. So my exponent is a positive 7. He moved 7 placeholders. Now what's the number left? This is 4.008. So 4.008 is my scientific number times 10 to the 7th power because I moved that decimal 7 places. So let's go ahead and do the second one. My decimal point is right here. I don't want it right there. I need it to go right here. So I need some number times 10 to my power. My original number is bigger than 1. That meant my exponent is going to be a positive exponent. I need to move my decimal 1, 2, 3, 4, 5. I need to move my decimal 5 place values. So my exponent is a positive 5. What number goes in front? That's a 2.35. So 2.35 is my number times 10 to the 5th power because I moved it 5 place values. Let's go ahead and look at the last one. Where is my current decimal point? If it's not written, it's because it's at the very end. You don't really write them at the very end. I don't want it there. I need a single number, and then I need my decimal point. So I need to go right there. So I'm going to come up with some number times 10 to the power. My original number was bigger than 1, which meant my exponent is going to be a positive exponent. Now, how many times did I move it? I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I moved 11 place values. So my exponent is going to be a positive 11. What's my number? It's 1.7. Everything else was zeros. So my number is 1.7 times 10 to the 11th power. Okay, so some more practice with scientific notation. If we're going to put it in scientific notation, I need some digit with my decimal. The rest of the digits can follow along. It's times 10 to some exponent. So we have 3 more examples to do. I see that my number is smaller than 1. If my number is smaller than 1, exponent is going to be negative. So I have something times 10 to a exponent. I'm smaller than 1, which meant my exponent is going to be a negative number. Now, my decimal point's currently right here. I don't want it there. I need to have a single digit between 1 and 9. There's my digit. The decimal point needs to be right there. So I needed to move 1, 2, 3, 4, 5, 6, 7, 8. I need to move 8 placeholders. So my exponent is a negative 8. What is my number? It's 6 point. So 6 point is my number times 10 to the negative 8. My number is smaller than 1. So when I'm coming up with my scientific notation, I'm smaller than 1. My exponent's going to be a negative. My decimal is currently right here. That's not where I want it. I want my decimal going to be right here because I need some number, decimal point, and then everything else. So I needed to move 1, 2, 3, 4, 5. I need to move 5 place values. So this is a negative 5. What's my number? It's 7.7. So my number is 7.7. Last one, I need something times 10 to a power for scientific notation. He is less than 1. Since he's smaller than 1, my power is going to be negative. My decimal is currently right here. That's not where I want it. I need a digit between 1 and 9, then my decimal point and everything else. So it needs to be moved 1, 2 placeholders. So I need to move 2 over, so my exponent's a negative 2. What's my number? It's 4.12. So 4.12 times 10 to the negative second power. Okay, so our last thing for today. If I gave you a bunch of scientific notation numbers, can you order them from least to greatest? So the first thing you do, step one is to first order it according to its power. And since we want least to greatest, our powers need to go from least to greatest. So looking for the smallest exponent that we have, the smallest exponent is a negative 4. Negative 4 is smaller than negative 1, 5, 5, 4, and negative 1. So we're going to write him first. He's out. The next smallest exponent, there's 2 of them. They're both negative 1s. So that's the first one in the list. The second one in the list. Going between 4, 5, and 5. 4 is smaller. So his number is listed next. 5 and 5, they're the same. So we're just going to write their numbers down. So the first step is to order them by their exponents. Since we needed smallest to biggest, our smallest exponent all the way up to our biggest exponent. Now that we have them listed by exponents, step number 2 is to order within the powers. And what we mean by that is you will notice there are 2 that have an exponent of negative 1, and there are 2 ordered within the exponent of negative 5. You need to make sure that these are written in the right order and that these are written in the correct order. He was already there, so he's going to stay. Now between these 2, we need to go from smallest to biggest. Between these 2, we already compared their exponents. We need to compare their numbers. Who's smaller, 1.2 or 1? 1 is smaller, so he needs to be written first, and then he can go second. The power of 4 did not have anybody competing, so he is still in his spot. Powers of 5, we already compared by their exponents. You now need to compare by their number. Who is smaller? Because we're going from smallest to biggest. Is 6.2 or 2.4 smaller? 2.4 is smaller, so he needs to be written first, and then the 6.2 can be written. And you have just ordered those from smallest to biggest, and you're done.
What did we learn today? I can evaluate and multiply by powers of 10. I can convert between standard notation and scientific notation, and I look forward to seeing you tomorrow in class.